Hi everyone, for this video I'll be going through how to upload an image to DESMOS and how to trace it using basic linear and quadratic functions. We can start off by uploading a picture or image that we've saved in the computer. To do this, we can move over to the plus icon over in the top left and selecting Add Image. From here we can upload our image straight onto the graph, just like this. We can then move our image freely, like this, or plug in specific coordinates over here. So let's center it on 0 at the x coordinate and about 1.55 at the y. Now we can start to trace our image using linear and quadratic functions. So to start off simple, we can draw the straight lines on our image using the linear equations. So linear equations are expressed by y equals mx plus c, where m is the slope of the line and c is where the line cuts the y-intercept. For the base of the bridge, we can see that it's a straight horizontal line going through about y equals 1. So if we want to go over to the left, we can type in y equals 1. However, we can see that this produces a continuous line without any boundaries. So in order to fit the bridge picture, we must restrict the domain for x. So if we see here, it goes just beyond -4, just beyond 4. So to do this, we've got to type in one of these curly brackets, go about -4.3, let's say, is less than x, which is less than 4.3, close bracket. And now we've got a nice straight line that fits our image perfectly. If we want, we can hide our image to see the line just by itself, just by clicking there, and we can click it again to bring it back. Now we can start to work on our pillars, which we'd be able to represent using vertical lines. We can see the end of this pillar here cuts at about x equals 2.7. So if we want to go over there, we can write in x equals 2.7. And again, we need to restrict the domains. So let's say 0 is less than y, and that goes up to about 3 is less than 3, close bracket. This next one cuts at about x.25, let's say. So let's go over here and do the same thing. X equals 2.25, open curly bracket, 0 is less than y, which is less than the same 3, close bracket. To do this next pillar, we can see that it lies at the same spot, just on the other side of the y-axis. So if we want to import over here, we can copy the same ones, but make them negative. So x equals -2.7, with the same domain for y being between 0 and 3. We can do the same for the other one, just by simply copying, pasting into the next bit, and changing it to be negative, like this. Now if we want to go up here and hide our image again, we can see that we've got our base and our pillars of our bridge. We can go over again to our cog if we want to change the colors at all. So let's make them all black. And click Done. Now we want to start working on the parabola in the middle, which we can make using a quadratic function. So if you want to use the vertex form quadratic function over here, we can type into the bottom over here, y equals a x take b all squared plus c. Again, we can add all our sliders for our variables, and this produces a parabola like this. Again, we can adjust our sliders so we can see that as a gets smaller, it fits our curve a little bit better. We can slide b to move it across. So let's put b about in the middle, and then change c, move it up and down to fit our curve. If we want our values to be more specific, we can click on the C value here and say 1.35 if we like. Here we can see it cuts pretty much right in the same spot as our image on the y-axis. Next, like before, we want to start to restrict our domains, so it cuts at the same spot as our pillars here. To do this, we can add the domain to our equation over here. So let's make it from negative 2.25, x is less than 2.25. We can also change our function so that we don't need our sliders anymore by replacing our variables with the values. So let's make a 0.3 and get rid of b and change c to 1.35. Now we can get rid of our variables for a, b and c. Now we can see this has produced our middle curve, and we can finally get started on our outside curves. We can see that these will be a similar function to our parabola in the middle. So to do that, we can copy our function down here and paste it again. And again, this produces our continuous parabola. However, now we want to move it along the x-axis to better fit our side curves. If we look at our quadratic function vertex form, we know that b corresponds to the value of the x-coordinate of the vertex. So currently b is 0 for this, which has it sitting at 0 for the vertex. So if we want to go down to our equation, we can insert a value of b, which would put the vertex around here. So let's say x take 4.9, and this fits our curve perfectly. Again, we want to restrict our domain, so let's make x go from 2.7 to about 4.3. For the other curve, we can see that's a reflection of the same curve we just made along the y-axis. So we can copy the same function, paste it down here, with the only difference being the value of b. So this one, the value of b was 4.9. This one, we want the value of b to be negative 4.9, which means we'll make it x plus 4.9, since it's a negative in the vertex form. Again, we need to restrict the domain, which will be a reflection of our last one. So negative 4.3 less than x less than negative 2.7. Now if we want to hide our image, we can see that we've created our simple parabolic bridge made entirely of linear and quadratic functions. Thanks for watching, everyone. I hope this has been able to help you recognize how to identify the curves of simple functions and understand how to plot onto a picture by changing variables and restricting domains. See ya.